Earth. So about 7:55 p.m. on the 25th Universal Time, or 2:55 Eastern Time, that's p.m., and 11:55 a.m. Or 2:55 p.m. on the Eastern and 11:55 on, oh, that's Pacific. So on the 25th. All of those are going to be on the 25th, and that's going to be about 194,000 miles away as opposed to 160,000 miles away from our Earth. So it'll get close to the moon as well as getting close to our planet here today.
And am I right in saying that this was we just learned about this a few days ago?
It was actually, yeah, a very recent discovery. It was first observed on January 20th of this year by PanSTARRS. That's the Panoramic Survey Telescope and Rapid Response System. What it is it's something that does scan the sky for objects like these, looking for those streaks in your sky. And it's located over in Haleakala in Hawaii. And it's discovered that very recently, and now we're actually experiencing that close approach just about 4.5 days later. And so they come and they go very quickly when it comes to these close approaches.
And Eric, this is one of what, a 500,000 that we've seen in the last 30 years. I mean, there are a bunch of them out there, aren't there?
It's amazing the history of us discovering all these asteroids because there's a whole lot of them out there. And yes, we've only recently, within the past few decades, really started to discover a big number of them. And so there's actually, and these are very rough numbers. People are estimating there's something about 150 million of these asteroids in the asteroid belt and closer that are over 300 feet. So a bit larger than the one that we're seeing. And those that are smaller, there might be quite a bit more of those as well. And just in these past few decades, we've really been able to knock down the numbers on these particular asteroids. The big ones we really know pretty well. We know about sort of more than 90% of the ones that are close by to us, that are about 3/5 of a mile, so really the large ones. The smaller that we go, the more unexpected that they can potentially be. For example, when it comes to the objects that are about this size, we really don't know all that many of them, and we don't actually know how many of them are necessarily out there. The reason that they're so surprising is because they're indeed so small. It's easier to see those bigger things, the things that look really bright, maybe that are bigger than, say, an orca whale floating out in space. And so it's a bit of a very, very difficult scavenger hunt, trying to find all of these objects of different varying sizes flying out around us, trying to narrow down where they might be, how many of them of different sizes that there might be. It's a very, very difficult task. But over these past few decades, astronomers have found a large amount of these asteroids, have continued to classify them into different types, so we're knowing better and better what lies beyond us every single day. It's a little bit of a comforting thought.
So, for the benefit of people at home, online, Eric, where on the screen should we be focusing?
So it should be somewhere actually right now, I believe, near the center of the image and moving towards, say, the bottom right. So going a little bit of a lower diagonal. And so if we look towards this image, we want to see something that's faint and maybe looks like a streak. This is an object that's going to be so dim that we're sort of competing with the limits of what this telescope can see. Even though this telescope can see very dim objects, this is sort of about at that barrier of what it can and can't see, what might be too dim for us to even visualize with this. And so this is another reason why these objects are so difficult to see, is because when they're so small and they're so dim, even really, really great telescopes can't see them all the time.
But it also makes it a little more special when we do find them, right?
Oh yeah, and I'm still holding out for that discovery that we get to see it here on this screen because I definitely think it's a possibility. And with the teamwork of our Sleuth community, I think there's the possibility indeed that we could just find it. So if you do find it on your screen, you're welcome to let us know, tweet at us, chat at us. We'd love to hear. We're also looking as well. I'm peering as I speak at this point, but yes, my goodness, I cannot find Waldo just yet. I don't know about you, Jerry.
Okay, we've re-nicknamed it. It's not Rerun anymore. It's Waldo. Oh, okay. Now here we go.
Oh, is that the circle? Is that it? I believe that might be that Slew team has circled it on the screen. So there is that tiny, tiny streak. That is Rerun or Waldo or 2017 VX. According to Slew astronomer Paul Cox, we are seeing that asteroid as it comes toward us on that close approach to Earth.
Fantastic. That is wonderful. Wonderful. So there you have it, folks. Rerun. Small asteroid. And the reason we are on the air right now. We're going to take a quick break, but we'll be right back here on Slew, so don't go away.
This February, a ring of fire will rise over planet Earth. Millions will be plunged into the moon's shadow as it races across the planet at supersonic speeds. The annular eclipse will make its way across South America, through Chile and Argentina, before crossing the Atlantic Ocean, making landfall in Africa, casting Angola, the Democratic Republic of the Congo, and Zambia into shadow. On February 26th, explore an eclipse like you never have before. Be a part of this worldwide event, right here on Slew. Space for everyone.
For everyone, Jerry Montero, along with Eric Edelman, our Slew astronomer for the evening. And we are tracking, as you can see on your screen, you see the circle, we are tracking a small asteroid called Rerun. That's the nickname. It's 2017 BX, and there he or she is. Eric, are they male or female? Ships are
It
female.
depends on the mythology. Earlier on, when we were naming the first asteroids that we were discovering, we did give them different names like Psyche or Ceres and Vesta, and so we celebrated them with stories of yore, things that we'd told each other before. And so those stories did have gendered people with them. And so in that way, perhaps we did have gendered asteroids. Now they're more into numbers and binary. So I guess then we would have to wander into the conversation. Do machines have gender? And I don't know if that's necessarily the conversation for today.
Okay. So, in case you missed it, folks at home, this is a small asteroid, and let's revisit the size and the scope of what we're looking at, Eric. It's basically the size of a fully grown killer whale.
Right, yeah, something that's about 10 meters or about 30 feet long. And it's also something that's moving pretty quickly, about 17,000 miles per hour, or 10 times the speed of a bullet shot out of an AK-47. It's on its close approach, it's getting about 160,000 miles away from our planet. And that's something about two-thirds of the moon's distance away from us. And to put that into more perspective, if you were to fly around Earth's equator, which is about 25,000 miles in circumference, you'd have to fly around it about 6.5 times to go out to the distance of this asteroid. And it's coming to its close approach to us. If you're in Europe, it's the morning of the 25th or the evening of the 24th if you're in the Americas. And so that's coming by really soon. We're seeing it leading up to that close approach. And it's amazing that we did get to spot it here on the screen.
Mm-hmm.
That's an exciting feeling.
It really is. It really is. And there's a view of the star field, courtesy of our half-meter telescope on the Canary Islands in Spain. So, Eric, here's a two-part question for you. Are we able to ever see with the naked eye an asteroid? Does that ever happen? And if it does that mean it's so big that we should be running for our lives?
There's a couple ways to think about that. We have seen asteroids with the naked eye when we experience those colliding with our atmosphere, like the Chelyabinsk meteor a few years back, and so we do have cause for concern if they can be visible to us. But then we have objects that are bigger, that are potentially still more distant from us, that are not right coming for us at that point in time. We have things called, great comets. Those are comets that are visible with the naked eye that come by us. So there are objects that are really, if they're big enough, then we can see them when they don't have to be a cause for concern. At the same time, I don't know, if a big object is getting anywhere near us, that sort of makes me uncomfortable too. In sum, no, we do not normally see these objects with the naked eye, particularly objects that are this tiny. There's no hope of you just going up or going out and looking up at the stars and trying to spot a rerun, to trying to spot 2017 BX. That's not going to be happening. But if there's a larger object out there, occasionally we can see it sort of close by. But yeah, it doesn't normally happen.
And just in case you're tuning in again, we have spotted it. There it is. That's rerun. That's 2017 BX. We put a circle around it for you because it is so very tough to spot. And it was discovered 4 days ago. Why is it that, Eric, why is it that we discover so many of these so late?
It speaks toward their size, really, because when it comes to asteroids, the smaller they are, the more of them are out there. That's what we've been coming to learn as we've started to look for these asteroids, to track these asteroids. The large ones, the ones that we, would be apocalyptic in terms of scenarios, we know that there are hundreds of those, where the smaller and smaller that you get down, you get into millions or hundreds of millions of asteroids. And also the smaller that you get, the more difficult they are to see. I mean, you can think about that when you spot something with your eye. Is it easier to see an ant, or is it easier to see the Eiffel Tower? The bigger objects are going to be more obvious for us to be able to spot. And I think actually a great sort of factoid that speaks toward that is earlier before the show, I just was looking into how many asteroids do pop by to us that get closer to us than they get to the moon. And over the past year, do you potentially have a guess, Jerry, as to how many asteroids came close enough to us to pass closer than the moon is to our planet Earth?
12.
12, and that's reasonable. Actually, according to the NASA JPL website, it was about 50 asteroids. And so that means we have an asteroid coming by us closer than the moon about once a week. And then I took that a little bit of a step further, and I looked out into the future. How many asteroids do we know that we've tracked, that we've identified? How many do we predict are going to be coming toward us throughout this next year? Any thoughts on what that number is?
I have the foggiest. Help me.
So two. There
Really?
are two, one of them being 2017 BX, or rerun.
Wow.
And then there's another one that we know of that's coming on, I believe, in October. And so my thought there is that we know about these asteroids in the past, but maybe there's a couple that we're not going to know about until they get a little bit closer to us in the future. And the pattern with all of those asteroids that were coming closer to us than the moon is all of those asteroids were really, really dim and really, really small. So really the tiny ones that we're not seeing, those are more prevalent, and they're going to be coming by us at different distances and at more common frequencies. And so that's why, maybe in the future, we're going to see a lot more of those surprises, because I don't think over the next year, it's just going to be two that get that close. It's just that we don't know about the numbers that are going to be coming by us. We haven't discovered those asteroids just yet, but we certainly will eventually.
Well, there is asteroid 2017 BX, nicknamed Rerun, in the circle. Eric, do we have any idea what Rerun is made out of?
So not to my knowledge. So when we look at these asteroids, what we do to figure out their compositions is that we look at the light coming to us from that asteroid. We look at that light curve. And so how reflective that asteroid is or not reflective, that's going to be something that tells us a bit about what it's made of, like things that are, if you look at a sheet of metal, right, or you look at a rock in the dirt, one's going to be shinier than the other. And so we look at what light is reflected from these asteroids when from the sun, and then we try and figure out what the composition of those asteroids are. And we know generally sort of the percentages of compositions of asteroids out there. We know a lot of them are stony. We don't see as many of the asteroids that are more of the iron type. And so, more likely it would be one of the stonier asteroids, but that I believe still remains to be seen.
And that's kind of part of the allure, isn't it? That we just don't know. I mean, it's an educated guess, but we don't know for certain.
Right, that there's so much that we're learning about these asteroids every single day. Just last week, I believe, the first asteroid that we ever discovered, Ceres, we learned recently that that asteroid actually has a thin covering of dust on it that's not related to its makeup. That it actually, a lot of other asteroids that they had been obliterated and their dust had settled onto Ceres. So this Ceres asteroid itself is a little bit disguised by the fallen corpses of its neighbors, so to speak. And this is something that we learned about, an object that we've known about for multiple centuries. And so every year, every day, we're learning more about the asteroids we know about. And then at the same time, we're learning about new asteroids. We're discovering new asteroids and discovering more about what they're composed of, what their story is. And all of those facts tied together help us to understand more and more about how our solar system has formed, how our planets, and a place for humanity has formed in this little tiny corner of the universe. And so, yes, the more and more that we learn about these objects and the more mysteries that we uncover about these objects, I think it takes us a step closer to just figuring out what surrounds us and how we relate to it.
Well, speaking of mysteries, it's my opinion, Eric, that one of the reasons we care about asteroids is because there's a certain mythology about them as well. I mean, we assume, at least a lot of us do, that it was a big asteroid that wiped out the dinosaurs, for instance.
A little bit of an apocalyptic sort of sheen hanging
Sure.
over them, that
Yeah.
potential for disaster, the potential for terror. It's one of those things that we've had movies about, the horror story scenarios of an asteroid coming toward us and not being prepared. It is in that way that sort of terrifying, sort of lifts the hairs on the back of your neck sort of feeling when you think about asteroids in certain ways. And I don't know, the good thing about it, at least for me, when I've looked into asteroids and I've learned more and more about them, is that when it comes to the apocalyptic, potentially dinosaur-ending asteroids, we know pretty much where all of those are, and we can feel pretty safe that we're prepared for those larger things. When it comes to the ones that are a little bit in between, a little bit smaller, we still haven't discovered all of those just yet, and that's where the potential for some damage lies. But yes, these asteroids tell a story, and they maybe speak toward a future that could be frightening. But we're working every day on trying to get better and better at figuring out where all of those are. And I suppose it's only a matter of time. And hopefully we'll get all that knowledge and research done in time to prepare ourselves for whatever might happen.
Well, you use the word prepare. How in the world, Eric, can we prepare for a large asteroid strike?
So the first thing is to know about it. If we know about the asteroid, if it is a significant enough asteroid that it's going to cause damage if it hits, if it's going to cause bad things to happen if it gets near us, then if we know about it in enough time, we have different scenarios that we could prepare for. And so we were sort of speaking earlier that asteroids, they're made of different things, they're going in different speeds, and so depending on the type of asteroid that we're talking about, there are different solutions that we could potentially put forward. A lot of them being maybe things that you're familiar with after seeing movies, like one of them is to just send a lot of nuclear missiles toward it. One is to actually just crash a lot of spaceships into it. One that I'm personally fond of, I think it's a really cool concept, is the NASA asteroid redirect mission, the NASA arm, where what it is sending this spacecraft out to sort of fly along with the asteroid and act as this sort of gravitational tractor, as to sort of move the asteroid slightly off of its trajectory so that maybe it will slip right on by past Earth. Though, interestingly enough, with this particular move, this particular idea of using the gravity of another object to aim the asteroid in a different direction, I believe it was Carl Sagan that talked about the potential issues that come along with that. That if we get really good at redirecting asteroids in the future, if we start colonizing other planets and humans on Earth, say, get into a skirmish with humans on Mars, could a redirect, a NASA arm, be used as a potential weapon in an interplanetary war? If we got really good at redirecting asteroids, could that be a potential for violence as well as a potential for saving people on our planet? And so the question as we develop these technologies becomes, as we start to harness the power of these asteroids, as we start to get better at controlling these asteroids, how good do we want to get at this stuff? As in potentially being worried about our capabilities being put in the hands of people that might use them for violence. And so there's a lot of questions and ethical concerns surrounding trying to protect ourselves from asteroids and what that might mean for us in the future.
Wow. Honestly, Eric, I was not ready for that.
I don't think any of us are.
You're literally talking about nudging asteroids out of the way. That's incredible.
Yeah, it's amazing what we can do at this point and what we can think about doing at this point. And I have to be honest with you, though, that the NASA arm is not functional right now. We don't have anything of that capability out in space. I think scientists are working on it right now. And if there were a threat that was imminent where we knew about it over like 4 or 5 years in advance, this is something that could be developed and perhaps utilized. But at this point, a lot of things are conjecture, suggestion. We're at this point where we don't know of anything that's really on our radar that's really concerning right now. So we're not in a race to develop anything. But if we were, those are a few suggestions that people put forward.
All right. Once again, the circle on your screen indicates exactly where asteroid 2017 BX, also known as Rerun, is in the night sky over Spain. At the moment. And one final thing before we let you go, Eric, what do these asteroids teach us?
Oh, that's a wonderful question. And I think you'll get a different answer depending on who you ask. For me, these asteroids, a lot of our conversation today was about protecting ourselves. So it sort of teaches us about our environment, teaches us to be aware of what's out there. But also, even beyond that, looking at these asteroids, they're sort of the building blocks. Our planets just didn't spring out of nothingness. When our solar system formed, there were initially these little rocks that collided together, snowballed together to become bigger and bigger rocks. And eventually those bigger and bigger rocks became small planets, and those small planets became the planets themselves. So when we look at asteroids, we look at our starting point. We look at where our environment began. We look at the cookie crumbs of the cookies that we're living on. And so looking at these asteroids, I think, helps us learn about our past, how we formed, and I believe it was, again, Carl Sagan who was talking about how we are star stuff. In another way, we are also asteroid stuff. Our planets are asteroid stuff. And so we're looking at what we've come to be.
Eric, it has been fascinating as always, my friend. Thank you so much.
Oh, thanks again for having me. It's so great to see it on the screen. Victory, my friends. We have found Waldo.
There it is. All right. Thanks again to all of you as well for watching tonight and sharing your questions with us. Rerun 2017 BX will be making its close approach in just a few hours, just before midnight, on the east coast of the U.S. You can learn more and continue your discussion over on slew.com, and stay tuned to that website because very soon there'll be a brand new slew.com coming your way, full of new ways to explore the universe and interact with other Slew members. Don't forget to join us next week when we celebrate Groundhog Day. We'll be talking all about how cultures have used changes in nature to predict the weather and mark time. That's Tuesday, February 2nd. And of course, we're gearing up for a number of eclipses in the coming months. On February 26th, it's the Southern Ring of Fire eclipse cutting across parts of South America and Africa. And of course, we're working hard on plans for the transcontinental eclipse in August. We'll be broadcasting the entire thing live from the path of totality. Join us on slew.com to follow all these events and more. Thanks for being with us. I'm Jerry Montour. This is Slew, Space for Everyone.